Hello, everyone. We'll be doing this lecture on sampling as we discussed in class. So in sampling, the goal, I'm going to start first with sampling in quantitative research because that's how most people think about sampling in relation to quantitative research, where you have a hypothesis, where you're selecting a group from a larger population in order to generalize to that population. But then we're going to switch and talk about sampling in qualitative research, which is very different. So the goal of quantitative research is generalizability. So the whole purpose of doing quantitative research is picking a representative sampling is very important. You pick a small group that's going to represent the larger population. And you have to sample correctly and accurately to be sure that whom you're getting the data from is representative of the larger population. Otherwise, you'll have errors in being able to generalize to that group. So population, you'll see in studies that we look at, is often referred to as N, capital N, the big N. So the group, and that is the group of individuals who share an important characteristic. So this is the population that you want to generalize to. So if you were doing a study of students at Providence College, the big N, the population, would be Providence College. That's who you want to generalize to. Now, instead of surveying 4,200 students at the college, you may be able to sample a smaller group and generalize to that population, big N, at Providence College. So in order to get a sample is small n, and that is the subset of the population that you're actually studying. And they're representative of that population, and you'll be able to generalize to the bigger group. So think of it, sample is the big whole, the population is the big whole that you're trying to generalize to. That population might be everyone in the freshman class, or it could be larger, it could be everyone at Providence College, or it could be even larger. It could be all students in college at the United States, that's a huge population, or it could be international. So you have to think about first, who am I trying to generalize to? What is the purpose? And then from there, once you know the population, then you have to figure out a way to come up with a sample or a subset to generalize to that population. Now, if you have a small population, let's say a program of 40 or 50 people, that's the population who you want to generalize to. If you have a very small population, it doesn't always make sense to sample, right? Or get a subset to generalize to the big set. In that case, when the population is small enough, so in program evaluation, it's smaller, then you want to survey your entire population. And you're not sampling at that point, you are simply selecting your entire population. Sampling is only when you take a subset of the population that you want to generalize to. Rule of thumb, if you have a population that's less than 100 or less, you might as well just use the whole population of going out for the survey. Now, they may not all respond to the survey, so you will have your response, your respondents will be less, but it's not because you purposely randomly selected a sample that's smaller. It's just because they didn't respond. And you can talk about that and talk about whether there's systematic reasons why those people don't respond. There's a lot of different approaches to sampling. So if you are generalizing to a large group, I would say, few hundred or above, you probably, instead of going out to the whole group, would want to get some kind of sample to be able to generalize to that population. So there are different approaches in quantitative research to doing that sampling. We're going to talk about probability sampling and non-probability sampling. So probability sampling are the techniques that a researcher offers to allow that every person in the population has an equal probability of being selected in the sample. So these are random sampling techniques. So probability sampling and random sampling are one and the same language for the same thing. And that's the chance that each member of a population will be selected for inclusion in the sample. And all members of the population have to have an equal chance of being selected for inclusion of the sample for it to be random sampling or probability sampling. So that means if you were trying to get to a population of Providence College, you would need a list of every single student, and each student would have to have an equal chance of being selected. It's sort of like putting them literally into a hat or into a sampling calculator in order to randomly select them, and everybody's got to have an equal chance. That's simple random sampling. There's also stratified random sampling, cluster random sampling, and I think I'm going to focus on those two rather than some of the others, because that's what you're going to see most in the studies that we look at, and it's what you'll be most familiar with. So let's take a look here at this figure. So if the population was 12,000 teachers in a district, a researcher could decide, you know, I don't want to randomly put all the teachers in one group because I want to stratify or get an equal proportion from the pop. So if I know of these teachers in a school district that in the population, the big N of the 12,000 teachers, that 4,200 are in elementary and that 7,800 or 65% are in secondary, so middle or high school. So let's say that's the population, so the big N. So we know it's 35% elementary to 65% secondary teachers in the big population. If what I want to do, I could put all of those potential respondents. I could decide, you know, I don't want to just do simple random sampling because I want to make sure that I stratify or get a similar number of teachers who are elementary school teachers to similar proportion of secondary that reflect the proportion in the population. So the proportion of the sample is proportional to what's in the population, and that would be a stratified sample. So in order to do that in this circumstance is you would get 175 teachers to 325 teachers. If you look at the bottom square here, so 135% or 175 teachers and 65% or 325 teachers from secondary, these would be a proportional sample to what's found in the population. So you could purposely decide, I want to sample 175 teachers from the district in elementary school and 325 teachers from the secondary level so that I have proportional or stratified sample that matches what's reflective in my population. Now here is an equal or non-proportional stratified random sampling. So in the last example, we figured out what percentage of the teachers were in elementary, what percentage in the whole population, what percentage of the teachers were in secondary, and decided that our sample, we would sample at those same proportions. Now this example here is that you would looking for equal number of participants to reflect the bigger population. So in this example, this is non-proportional. It's equal, but it is stratified, meaning that it's looking at a subgroup and making sure that you have representation from those subgroups because that's important to you in this circumstance. So if the population is 12,000 teachers in a school district and you wanted to break that into the two subgroups to make sure that you have representation from the elementary school teachers versus the secondary school teachers. In the population, the proportion is more secondary teachers, 65%, to less elementary school teachers, 35%. However, the way that you decided to go about sampling here is you wanted to equally get the sample. And if you were to do that, you would do 50-50. So you would say, I want to randomly select 250 teachers from elementary and 250 teachers from secondary. Now that, if we toggle back, to the previous example, you'll see in this example, we have 175 teachers we would sample if we wanted to keep it proportional to 325 teachers in here to keep it proportional. So you can take either approach, and there's rationale to each. Neither is wrong, but you need to know which approach you're doing and be selective about it, whether you want to do proportional or you want to do non-proportional. So take this example and maybe think about a survey you might be doing for your project. So if you plan on your project that your population is a small group of 20 people who participate in an online training and 20 students that don't in higher ed, and your population is 40, in this case here, you don't want to sample. You want to use the entire population and hope that they all participate because they're such small ends. However, if you wanted to survey and generalize to all the students in the first year, and there were 1,000 students in the first year, you may decide you don't want to do all 1,000 students, the population, the big N. That maybe what you'd like to do is to ensure that you have proportional representation of first generation students in the first year. So you would have to know what that looked like in the population, and then make sure when you did your sample that you selected the similar percentage in your sample. Glad to answer questions about that in class. So non-probability techniques. So you've got probability or the random sampling techniques on the left. We talked about simple random sampling, that's throwing them in the hat. And now we've talked about stratified random sampling, and that can be either proportional or non-proportional. In stratified random sampling, you're looking at figuring out a strata or a subgroup within the larger population that's important. And the case that we looked at, it was elementary versus secondary. But there could be examples where the strata is low income, medium income, and high income. It could be first generation students and those students with pre-college experience in AP classes. So it's up to you to decide if you have strata and whether it's important to make sure that each of the strata are represented, because then you might want to take a stratified random sampling approach. So in the example where your population is the entire student population at Providence College, 4,100, and you want to ensure that you are getting responses from first year, sophomore, junior, and seniors, those different classes, first year, sophomore, junior, and senior would be strata. You would find out if they're equal strata. In that case, it would be proportional, and then you would make sure that you have selected students from those strata to be sampled. Now, another approach that we'll talk about is cluster random sampling. And that is sort of right for looking at student learning kind of data. And that is when you randomly select a cluster or a group that is already put in place that you didn't put in place. So a perfect example in school would be classes, whole classes. So students have already selected their classes. You didn't put them in those classes. They just went and they scheduled. And you have 10 sections of Western Civ. And you decide that you randomly want to select half of those sections to participate in a study that looks at a new teaching approach toward Western Civ. So you would take each of those 10 clusters or classes, put them in a hat, and then randomly pick out which one would get the new instructor. That's cluster random sampling. So looking down at this list here on this side, this simple random sampling, this would be the strongest type of sampling that's going to get you the most generalizability. Strata would be next. Cluster would be next after that. And I say that because this is where you're taking the researcher out and there's the most chance that anybody could be selected. You're getting a little more purposive here, but you're pulling away from random sampling. So in a true quantitative researcher's lens, this would be something that someone could critique, that you are looking for certain groups. And then when you get to cluster, because students are already put into these groups and you didn't have control over that, and they could already be differences among those groups, you might be randomly selecting the clusters, but you didn't have control in the assignment into the cluster. Because you had less control, it's seen as being weaker than the other. Now, don't get me wrong, these are all still very strong approaches on the left side. These sampling approaches on the left side, and I'm going to skip these other here because you're not probably going to see them as often, and I would focus on these three. This is what you see and hear about most. These would be seen as the strongest sampling techniques for a quantitative researcher, and the closer you get up here, the stronger it is. On this side here, on the right side, we have the non-probability or non-random sampling techniques. And this can be done in quantitative research, although they are critiqued as not being as strong as the probability or random sampling techniques, because the researcher, there could be bias in the way that you're making the selections. So that's a ripe area for critique of others, but it may be the best that you can do depending on the situation that you have. On this side, and we're going to talk about these in a little bit, we'll also see some of this same language of the non-probability sampling techniques being used in qualitative research, because qualitative research is not generalized the same way quantitative research is. Qualitative research is set out to describe a specific group, and it's usually a small specific group, and you don't usually have sampling in the same way you do for quantitative. You do sample, you might pick a subgroup rather than a population, that's sampling, but it may look a little different. So moving ahead in terms of sample sizes, I'll come back to the non-probability sampling. We'll look at some qualitative research in a moment. So what size do you need when it comes to sampling? Certainly, it has to be large enough to provide minimally adequate representation of the larger population. So size is often a critique in quantitative research, but there are calculators, and I'll show you that in class. I'll give you a couple of links to sample calculators, and we'll take a look at those together. But here's some general rules of thumb. For correlational research or causal comparative research, now remember, correlation is not causation. Correlation is having a relationship between two variables, but it's not necessarily predictive of each other. In that case, you need a minimum sample size of about 15 in each group, or a minimum number of 30 to be able to do correlational research, to be able to look at the variables in relation to each other. In survey research, you usually need about a minimum of 350 to generalize to any large population. When we check out the sample calculator, you're going to be surprised at what this looks like. But you need a minimum of 350, and that's to generalize to 1,000, to 2,000, 5,000, 10,000. And we'll take a look at the calculator, but I might think that it might even go up to somewhere around 90,000 or 100,000 before you get to a break point where you might need to actually survey a little more. And that seems to be hard for people to understand, that whether you're generalizing to 1,000, 10,000, or 100,000, you only need 350 people if you're doing random simple sampling. So typically you need 10 to 20% of a population size, but this is highly dependent on the size of the population. Remember, the big N. So the small n is highly dependent on the size of the large N. But once you get to about 350 or 400 in your sample, you can generalize to pretty large populations. If you have a small population, so a small big N of 100 or less, you might as well not even bother sampling and just survey or select the whole population to participate. Again, here are some sample size guidelines. So if your big N is less than 100, do your whole population. If your N is between 400 and 600, it's about 50% of your population. If your N, and remember N is population, so if your population is around 1,500, think about 20% should be sampled. And if your N is larger than 5,000, it's almost irrelevant because a sample size of about 400 is accurate to almost any size population. Other issues with sampling are sampling error and sampling bias. So sampling error is the chance of variation resulting in a lack of representation. And that's an error that the researcher didn't have any control over, and it just sort of happened by chance. So if I threw all of the names of all of the students in Providence College literally into a hat, and when I picked them out, I picked all white students, there would be sampling error because we know that there's students of other races at Providence College. The fact that I didn't pick them and everybody had a chance to be selected because everybody's name was in the hat was a sampling error. So it wasn't my fault. I didn't do anything wrong as a researcher, but the chance or probability just didn't work out. So there's an error there because when I did the sampling, it didn't really match the population. Now, sampling bias, on the other hand, is different than sampling error because that's a systematic sampling problem that's usually the fault of the researcher. So it is your fault. So if when I was putting all of these names into the hat, Gary? So if I was putting all of these names into the hat, that would be systematic sampling error. And that's usually the fault of the researcher. So I put them all in a hat and I missed the last page of all of these lists when I was putting them in the hat. So I systematically left out everybody with the last name that began with Z. Not on purpose, but by accident. That would be sampling bias because they did not have a chance of being selected. So we have to determine to the extent in which sampling error or sampling bias impacts our results and could impact the conclusions. We've discussed scales of measurement, so I'm going to stop sharing my screen there. I'm going to reshare the screen and come back to the non-probability areas. Bear with me as I get to the non-probability errors. Okay. So the next PowerPoint that I'm going to go through are the non-probability sampling techniques. I hope you're fast forwarding me. Okay, here we go. So in qualitative data collection, we have the non-probability sampling techniques. And those targeted, so when you're sampling in qualitative research, it's almost exactly the opposite of quantitative research. The whole point of sampling in quantitative research is to take the bias out, is to make it objective, and so everybody has an equal chance of being selected, and it's extremely objective so that you can generalize to that bigger population. Now, qualitative research, on the other hand, is actually a targeted approach to sampling, where you're purposely sampling and intentionally picking certain individuals because they are representative of a particular case. So the word sampling is used in both circumstances, but they're very, very different. One is objective in quantitative research and stripping out bias, and it's completely objective. And on qualitative research, exactly the opposite. It's intentionally selecting cases because you want to study those cases. I think when people think about sampling, they think about quantitative sampling, but you can use sampling, and you do use sampling in qualitative, and it's used in a very different way. Now, be careful about critiquing qualitative researchers for having an intentional sample collection, because that is the purpose of sampling in qualitative research, right? So these are the many different types of purposive sampling strategies. I'm going to focus on some of them that I think we're going to see most often when we look at studies. But all of these are purposive sampling strategies, meaning you're purposely going out to select samples because they are very particular and because you want to look at them. Very different than the non-probability sampling approaches we just talked about in quantitative research. So let me see this here. This looks small to me. I want you to see this a little bit bigger. Hopefully that's a little bit bigger for you. So these are the types of purposeful sampling techniques. So on the left side, you're going to see the sample is selected before data collection begins in qualitative research. So before you go about doing your interviews or your focus groups or whatever approach you're using for qualitative, before you go out selecting those cases, you could do maximum variation sampling, where you want to get a variety of different people or different groups in it, so you get many different perspectives. Think about triangulating perspectives. You could be doing extreme case sampling, where you're actually looking for the outliers to understand why things are so different. So think about if you wanted to look at students who dropped out of college in their first year, they might be extreme cases of because they're the handful who dropped out, but you want to understand what was particularly troublesome to shed some light on those cases. That would be an example of extreme case sampling. Typical sampling means you want to get the typical case, so you want to get the typical first-year student. So you start sampling what you think would be typical first-year students. Critical sampling That's to get a case that dramatically exemplifies a situation. So, a case or that is that dramatically shows what's going on. Homogeneous sampling is to describe a subgroup in depth. So it might be all of the students who failed Western Civ or got A pluses in Western Civ. So you want to understand that subgroup, and you just want to understand those students. You don't want to understand the typical student. You just want to understand this very small group that had this experience. On the right side, you're going to see all the samples that happen after data collection has started. Some language that you'll hear about after data collection has started is called post hoc, or after the fact. So that's after the case sampling. That means that things just happened, and now you're looking back to choose cases to illustrate something. So you didn't actually sample before something happened. You're actually looking back, and after the case are looking back to select opportunities. So that can be opportunistic, snowball, confirming, and disconfirming sampling. Now in snowball sampling, you'll hear this language a lot. That's when you locate people or situations in a study, and then you have those participants identify others that have had similar experience sort of after the experience has happened. So you're looking at a situation after the fact, and then you find one person who had this experience and ask for recommendations of others. So you do this when, let's say it's a very hard to reach population. Let's say it's an underground population. So if you wanted to do research on, let's say, gangs in schools, it's not like you can go get a list of every gang member. It's not like they keep a database. I don't think that they do. So instead, you find a gang member and you ask the gang member if they have friends, and you start reaching out to the other gang members. So there's definitely, bias and connection, but it might be the only way for you to actually get those samples. That's called snowball sampling. Think of a snowball running downhill. You start picking up cases as you go. Opportunistic sampling is also called convenient sampling. You'll see that. And that's when a researcher just takes advantage of participation as the case has already happened. You're just after the fact. You hear of people and you start reaching out to people to get their experience. Sampling in qualitative studies, the sizes can vary greatly. It's going to be much smaller in qualitative research than it is in quantitative research. And depending on a particular qualitative methodology that you're employing, some qualitative research studies only require one site or one participant. Think of a case study. That's a qualitative approach, and you only have one site. Or a leadership study that looks at CEOs of companies might look at 3 or 4 CEOs just to look at their experience and how they became a leader. Others could need as much as 40 interviews, but usually your sample size is relatively small in qualitative research. People will critique you for that, but I'm here to tell you it may be appropriate for qualitative. And that's because, as we've discussed in class, the data is very hard to collect, it's voluminous, and it takes a long time to analyze the data, and you're getting narrative data that's very in-depth, which is very different than survey data, which can be popped into a spreadsheet and analyzed rather quickly. So the approaches that you would get to that sampling would be observations, interviews, and focus groups. Let's talk a little bit about observations. Those observations can be structured, semi-structured, or unstructured. Observations are carefully watching and systematically recording what you see and hear in a particular setting. So some people use observation protocols, where a written checklist, where I know exactly what I'm looking for, but that would be a more structured approach. A semi-structured approach, you might have a checklist, but also be making notes of just things that weren't on the checklist that you happen to see until you see a pattern. And then unstructured would be, you have no checklist. You're just going to go and sit in a classroom and watch how the faculty member interacts with a student, for example. And you don't know, you don't have planned out what exactly you're looking for because you don't know, and you're just waiting to see the patterns emerge. There's obviously pros and cons to each. A quantitative person would argue you'd want the most structured observation in a checklist style as possible, but somebody else might say, gee, you might not know exactly what you're looking for, and maybe you should just sort of go there, observe, videotape, etc. Observations can be done with the researcher participation. Sometimes the researcher is just an observer. So think about somebody from the outside coming in and observing a class with students and teachers. But sometimes the observer is also a participant. And that might be, for example, the teacher is teaching but also observing student behavior at the same time. Some people would say that there's a lot of bias there. Others would say that that bias is good. And a full participant would be maybe the observations of the students who are fully participating in the class, making observations as they go. So with observations, you can go about observations by taking field notes where you have observations of what you're seeing taking place, or having comments. I want to talk more about interviews because this is going to be the focus of our next class. Interviews are conversations between the researcher and participants in the study. Interview guides are very important to develop and use. And just like with observations where you have structured, semi-structured, and unstructured, interviews are the same. And there's pros and cons to each. You can have a very structured interview that is almost like a written survey that you're reading off, and you're reading them exactly the same, and you might even have response choices that they can choose from, and you're doing it exactly the same with the same interviewer, with the same with different interviewees, so that you're controlling how the interview happens and that they all happen in a particular format to add as much control and structure as possible. Obviously, quantitative researchers, if they're going to do anything that's more on the qualitative side, would prefer a structured interview because it takes out a lot of bias of the researcher, and you know what you're looking for and you set them out the same way, and there's a lot of control. Semi-structured are probably the more popular approach, particularly if you have a qualitative research question, because you have a guide of maybe 5 to 8 questions, but you're leaving open, depending on the participant's experience, to see what they have to say rather than force them into answer choices, and to sort of listen to what their stories are. And then unstructured would be you don't have an approach to the interview. You know, you have a big guiding question and you're just going to go in there and talk, and it's going to look really different from each participant to each participant where each conversation goes. So there's a lot of critique in terms of unstructured. I tend to think semi-structured is sort of middle of the road. It allows some flexibility for the researcher and for the participant, but it also has some degree of focus and purpose up front, and you're going in with a set of interview questions. There's definitely pros and cons to each. And interviews can either be group interviews, which are focus groups. This slide says no more than 12. I think the reading you said 5 to 8. Should be sort of a smaller group, a manageable group of people. Focus groups allow for people to feed off of each other and to comment, but you have to ensure that nobody dominates, so it takes a lot of facilitation. Bigger focus groups, I always recommend that you have a researcher and an observer so that they're keeping notes. Then there's journals. There's important sources of data generated by participants themselves. I want to just focus on the interviews. I think this covers sampling pretty well, gives us a little bit of introduction into interviews. We'll lean heavily on our readings when we meet. We'll talk more about interviews. I'll answer any questions about sampling. And then we'll dive into developing our own semi-structured interview questions and talk about what makes a strong interview question. Thanks for your time. Talk to you soon.